Hi. In this video, I'm going to talk about problem 6.18, which was number 5 on the chapter 6B homework, one that a number of people asked about. So first off, we've got a roller rink and two 20-kilogram girls accelerating toward each other until they're each moving 2.5 meters per second in the Earth reference frame, which is the reference frame of the roller rink. They then collide stomach to stomach and grab onto each other and then fall to the floor. So they're coming at each other, they grab onto each other, so they're stuck together. That makes it an inelastic collision. And then they fall to the floor. That suggests they stop. So drawing that situation real quick, we've got one person, other person, I'm not going to draw the skates, going right at each other at the same speed, 2.5 meters per second and 2.5 meters per second, and they're each the same mass, 20 kilograms. So 20 kilograms, 20 kilograms, plus 2.5 meters per second minus 2.5 meters per second. Okay, so the question's asking about magnitudes of momentum. The momentum of this first one is 20 times 2.5, which is 50. So P1 is plus 50. P2 is minus 50. And they're asking for the momentum of each girl, the magnitude before and after. So before, they each have the same momentum of the same magnitude of 50. And then after, because they grab onto each other and stop, totally elastically, they stop, that means afterwards the momentum is 0. So let me just draw that after real quick. Stopped, V equals 0, M equals 40 kilograms. Okay, I'll submit that, and you'll see that that's correct. Okay, now we're going to switch to a different reference frame. So we have the reference frame of a mother who started skating with one of the girls and then continued on after the collision without changing speed. So from that person's point of view, one of the kids is not moving and the other one is coming at them faster, okay, initially. So that person has a perspective that one of them is stationary. So we've got V equals 0, and the other one is going at velocity equals minus 5. Okay, so before the collision, this one has a momentum of 0 according to the mother, and the other one has a momentum of negative 100. The negative 5 meters per second times the 20 kilograms. Okay, so this question is asking about the momentum of each of the kids, both before and magnitude. So I'm going to drop the signs. So one of them is 0 and the other one is 100. Okay. And now, what are the magnitudes of the momentum of each girl after the collision in the reference frame of the mother? Okay, so what is the mother going to see? The mother initially sees one of them not moving and the other one coming out really fast. Then the mother's going to see them hit and stick together. The fact that they stick together after the collision is not going to be different for different observers. But then because the mother is continuing to go on, that the mother's going to see both kids go the other direction backwards. So they will see a hit and go that way. So drawing that really quick from the mother's perspective, they're now stuck together going backwards. From the mother's perspective, the momentum of that system is not going to change because the momentum doesn't change from anyone's perspective. So since the total momentum of the system was negative 100 before from the mother's perspective, it's still going to be negative 100 afterwards. And from that, you can figure out what speed the mother will see for the two kids. But the question is only asking about the momentum. So the momentum of each girl after the collision in the reference frame described in part B. Okay, so the total momentum is negative 100. That means each one of them is going to be negative 50. We're asking about magnitude, so we're going to drop the sign and There we go. So there you go. Those are the answers for that. And the key there is thinking about what's the perspective of the person watching and what things are the same for that person watching and what things are different.